This video provides easy-to-follow instructions for you to create this Geneva Cam using Onshape. Click below in the video description. Here you will find links to all of the resources you need to complete this project. First, there is a link for a PDF instruction sheet. Click this link and open the project drawings and specifications in a new browser tab. Next, if you don't have an Onshape account, use one of these links to create a free account at the Onshape website. Last, there are links for each of the segments of this video. The video instruction is organized into 5 segments. In Segment 1, you will read the engineering drawings. Segment 2 will establish the design intent. In Segment 3, you will create the part model using Onshape. Next, you will check the accuracy of your model by checking its mass properties. Last, you will check the design intent by making changes to the model to see if it will update correctly. Now you are ready to begin the project. In this segment, we'll read the engineering drawing for this part called a Geneva Cam. The drawings provide all of the information we need to model this part using Onshape. Let's start by identifying the views provided in the drawings. This drawing contains 2 standard view types to fully describe the shape and the size of this mechanical part. First, the isometric view shows a pictorial. This helps us visualize the part in 3 dimensions. Next, the orthographic drawings show 2 principal views. To the left is the front view. Aligned to the right of the front view, the right side view. This view is shown as a full section view. The cutting plane line, shown in the front view, shows the location of the cut, and the arrows indicate the view direction of the section. The hatched section lines in the section view show where the solid material was cut to show an interior view of the part. When preparing to make a feature-based model, we need to identify the basic shapes and features combined in the part. One feature I notice is that the shape is symmetrical both top to bottom and left to right. That the basic shape is circular and the circular features are all concentric to the center of the part. That there is a pattern of slot and arc features evenly spaced around the flat circular disc. Concentric to the center, there is a thicker circular hub that extends in front and in back of the disc. Next, we'll look at the dimensions and notes. First, the measurement units are in millimeters. The outside of the plate has a diameter of 150 millimeters or a radius of 75. The outside diameter of the center hub is 45 millimeters. The center hole diameter is 25 millimeters. The slot is 12 millimeters wide. The radius of its semicircular end is 6 millimeters. The center point of the semicircular end is located on a concentric center line circle that has a diameter of 75 millimeters. This places it 37.5 millimeters from the center. The outer arc has a radius of 30 millimeters. Its center point is the intersection of 2 construction lines. First, a center line circle with a diameter of 180 millimeters, and a construction line that extends from the center at an angle of 30 degrees from vertical, or 90 millimeters from the center. The center hub has a diameter of 45 millimeters, and the center hole a diameter of 25 millimeters. The center hub has a total thickness of 20 millimeters, and extends 10 millimeters from the front face of the plate. It extends 5 millimeters from the back face of the plate. The thickness of the circular plate is 5 millimeters. The material is ABS plastic, and the mass is in grams. Before we model the part in Onshape, let's review the design intent. For this project, we intend our model to be flexible to possible design changes so it will behave predictably if revised. To start, we need to identify any features that might be changed during the design process. First, the size and locations of the arch and slot features that are patterned around the outside of the disc may change. Also, the total number of instances in the pattern may be increased. Last, the diameter or width of the center hub might change. Next, let's identify the features that should remain unchanged after a revision. The outside diameter of the plate will remain the same. The circular symmetry, as viewed in the front view, will be maintained when revised. So while modeling the part in Onshape, we want to consider the order that features are created and constrained to ensure when the model is revised. It will update predictably without errors. To start, let's preview the steps we will use to model the Geneva Cam using Onshape. Then we will demonstrate each step in detail. First, we will choose the front view for our base sketch and place sketch 1 on the front sketch plane. The center of sketch 1 will be coincident to the origin on the sketch plane. Sketch 1 defines the size of the disk and hub. With Extrude 1, we will create the base feature, the disk. In Sketch 2, we'll define the size of one set of the pattern elements. With Extrude 2, we'll remove material to create one instance of the pattern features. In Circular Pattern 1, we will distribute the features about the center of the disk. Lastly, in Extrude 3, we will use elements from Sketch 1 to create the center hub. This completes the model. I've started a new Onshape document and named it Geneva Cam. Before starting the sketch, I want to check my workspace units. Make sure the length is set to millimeters and the mass is set to grams. I'll start a new sketch in this part studio. Click on the front sketch plane. Use N on the keyboard to view normal and P to turn off the visibility of the sketch planes. From the toolbar, choose Center Point Circle. Click Coincident to the origin to start the circle. Enter 25 for the diameter of the center hole. Click Coincident to the origin again to start another circle. Enter 45 for the diameter of the hub. Click Coincident to the origin again to start another circle. Enter 150 for the outside diameter of the plate. This looks correct. Click the green check to end the sketch. We can now use the outer region of Sketch 1 to extrude the base feature. From the Feature toolbar, click on the Extrude tool. This will be new. Click on the region of the sketch that forms the outer disk. The direction should be in front of the sketch plane. Set the depth to 5 millimeters. This looks correct. Click the green check to accept and create the base part. Notice, Extrude 1 is now listed on the feature list. Next, in Sketch 2, we will define one set of the elements that will be used to create this circular pattern. We will use construction circles and lines to find the locations for the arc and slot elements of the sketch. From the toolbar, click to create a new sketch. Click on the front face of the plate to select it as our sketch plane. Use N to view normal to the screen. From the toolbar, click Center Point Circle and click on the Construction tool. Click Coincident to the center and enter 75 for the diameter of the first construction circle. Again, click Coincident to the center and enter 180 for the diameter of the outer circle. Next, from the toolbar, click on the Line tool and the Construction tool. Hover at the origin and move the mouse up vertical to the small construction circle. When you see the vertical and coincident icon, click the mouse to start the line. Drag the line up to the outside edge of the disk. When you see the vertical and coincident icon, click to place the end of the line. This line will be used to define the slot. From the toolbar, click on the Slot tool. Click on the vertical construction line to place the slot. Double-click on the diameter and set it to 12 millimeters. Left-click the mouse to end the Slot tool. Next, we need to locate the center of the outer arc using a construction line. Click on the line and the Construction tool. Click Coincident to center and drag the line up until it is coincident with the large construction circle. On the toolbar, click on the Dimension tool and set the angle between this line and the vertical construction line in the slot to 30 degrees. To make the arc, click on the Center Point Arc tool in the toolbar. Click on this intersection as the center of the arc. Click on the edge of the disk to start the arc and click again for the endpoint. Set the radius to 30 degrees. This defines the two elements we will use for the pattern. Click the green box to accept the sketch. We can now use the elements in Sketch 2 to extrude remove material. This will create one set of the features we will use for the circular pattern around the outside of the disk. Choose the Extrude tool from the Feature toolbar. Click on the Remove option in the dialog box. Click on the arc and the slot regions in Sketch 2. For the end type, choose Through All. This looks correct. Use the green check to accept. We can now use the Feature Pattern tool to distribute this feature set around the disk. From the Feature toolbar, click on Circular Pattern. From the drop-down menu, click on Feature Pattern. For Feature to Pattern, click on Extrude 2 in the feature list. For the axis of pattern, click on the circle at the center of the disk. For the instance count, enter 6. This is the total including the existing feature set. This looks correct. Use the green check to accept and close. Next, in Extrude 3, we will add the center hub to the part. In the Feature toolbar, click on the Extrude tool. Click on Add. For the sketch regions, go to Sketch 1 in the feature list and click on the eye to turn on its visibility. Notice that the sketch plane for Sketch 1 is on the back of the disc. All of our extrusion distances will be measured from this sketch plane. Click on the hub region of the sketch, leaving the hole unselected. The direction should be forward and set the depth at 15 millimeters. In the dialog box, click the checkbox for second end position. Enter 5 for this depth. This is the depth the hub extends from the backside of the disc. This looks correct. Use the green check to accept and close. Next, we can change some properties for the part. Right-click on the part in the parts list and choose Rename. Change the name to Geneva Cam. Again, right-click on the part in the parts list and click on Edit Appearance. Choose an appealing color. Now the Geneva Cam is complete. In this segment, we'll check the accuracy of the model by checking its mass properties. To check the model, the mass unit should be set to grams and the material set to ABS plastic. If the size and shape of your model was completed accurately, the mass should be 76.468 grams. Let's review this process step by step. First, open the document that contains the model of the Geneva Cam. Next, check the workspace units and make sure that mass was set to grams. Next, we will set the material to ABS. Go to the part in the parts list. Right-click and click on Assign Material. In this case, we're searching for ABS plastic with a density of 0.001. Click to select it. Next, go down to the lower right corner and click on the Display Mass Properties button. When the dialog box opens, click on the part, and the display shows a mass of 76.468 grams. If this was your result, then your part is accurate and matches the specifications. If the mass of your part does not match, let's troubleshoot each feature to look for an error. First, locate the rollback bar in the feature list. Move the rollback bar up so that only the Extrude 1 feature is displayed. The mass reads 84.586 grams. If this is not your result, look for an error in the sketch or features included in Extrude 1. When your value is correct, move the rollback bar down the feature list to the other side of Extrude 2. The mass is now 79.377 grams. Again, if your mass doesn't match this amount, look for an error in the sketch or feature. Now, after making any corrections, move the rollback bar to include Circular Pattern 1. The mass should now be 53.333 grams. And last, move to the end to include Extrude 3. The mass should now be 76.488 grams. At this point, if all of the previous features were correct and your mass is wrong, then the error is in Extrude 3, the hub. In this segment, we will make some revisions to the design and check if our design intent has been applied correctly. We will start by reading the revision drawings to identify the features that will be changed. First, the length of the slot has been shortened. This is shown by the change in the diameter of the center line circle. It is now 90 millimeters. The number of instances of the circular pattern is changed to 8. This changes the angle between the slots to 45 degrees. From this, we can calculate that the center of the arc is now 22.5 degrees from vertical. The radius of the arc is now 25 millimeters. Also, the depth of the front hub is now 20 millimeters. This distance is measured from the back of the plate. We should also note the features that will not change when the design is revised. The width of the slot continues to be 12 millimeters. The outside diameter of the plate is still 150 millimeters. The diameter of the center line circle, used to locate the center of the outside arc, should remain at 180 millimeters. After accurately making these revisions, the new mass will be 85.558 grams. Now we will make the revisions to the part. We can revise the part in a new part studio by duplicating our original Geneva Cam. Right-click on the Geneva Cam Part Studio tab, and from the pop-up menu, click on Duplicate. Right-click on the tab of the copy and click on Rename. Call it Revision 1. Click on the tab to open it for editing. We will start with Sketch 2 in the feature list. Double-click to open Sketch 2 for editing. Use N on the keyboard to view normal to the sketch. We will start with the slot length. Change the circle diameter to 90 millimeters. Next, change the radius of the arc to 25 millimeters. Last, update the location of the arc by changing the angle of the construction line to 22.5 degrees. Use the final button to preview the changes. This looks correct, so click the green check to close. Now, double-click on Circular Pattern 1. Change the instance count from 6 to 8. Click the final button to check. This looks good, so use the green check. Last, we need to edit the hub. Double-click on Extrude 3. Change the depth of the first end position to 20. Click the green check to accept. With all of the revisions completed and no errors in the feature list, we can check the mass properties to make sure the revision is accurate. Click on the mass properties box and click on the part. The mass should read 85.558 grams. If this is your result, you have completed the revisions correctly.